Hi, this is Elkin. We are a Technaid Research Digest podcast. Here we talk about technologies related to exoskeleton and human motion rehabilitation. Because we are strongly involved in research and technology, we're very interested in knowing emergency research, especially from our partners and customers. Today, I have the pleasure of introducing to Dr. Joana Figueiredo. She's currently a postdoc research in Minho University. So, welcome, Joana. How
Hi.
the things are going today?
Very well. And you? And you're fine?
Great. Just suffering a little bit with the weather here in Madrid. I suppose in Portugal it's better because,
Yes, it's pretty better than the other side
yeah,
of the.
yeah. Thanks for attending today. Maybe you will start your holiday, so we really appreciate this time with us.
Okay. Yeah.
So let's break the ice today. Maybe you can talking a little bit about your background and how you start working with this world with exoskeletons.
So it is an interesting story. I'm a biomedical engineer. I did the
Okay.
master and the PhD as well on biomedical engineering. Some years ago, 8 years ago, almost. I have doing my master thesis, and I decided to do it on the exoskeleton topics. So I have contact Professor Cristina Santos because this topic was highly related to my motivation to do with my master thesis. And I talked with Professor Cristina, and she agreed as well to join to this adventure because the research on this kind of technology in Portugal at that time were quite delayed because I didn't know any group working about exoskeletons, in particular for gait assistance. And so it was quite interesting because we have started a new research topic here in Portugal, in particular at the University of Minho. So she agreed to start this project, and then we have looked at for partnerships to do Erasmus because I have decided to do Erasmus to get knowledge around the gait assistance using exoskeletons. And from this research, we have found neurorehabilitation group from Carral Institute that are partners from Technaid. And then this adventure has started like that. I did my Erasmus with with Juan Moreno, and I have started working near with researchers that have also contributed for H2 technology. I have learned a lot of things with this research team. And at that time, I had also opportunity to see Technaid facilities as well. So
Yes.
it was a great experience for me almost 8 years ago. After that, Professor Christina asked to do the PhD on this topic. I have thought about that and start the PhD. So the things start from my PhD, the project as well around these topics have started from the partnership between the neurorehabilitation group from Carral Institute, the University of Minho, and during this period we have joined different partnerships, including end users from Hospital of Braga, different local companies that have joined to us to improve the technology. So this is a brief history. So from this period, we have working a number of master students. We have another right now PhD students working on this project. So it is begins with a small my motivation and idea, and then it works and results on a great project.
That's amazing. I mean, a really good story because you look really motivated, still working with this kind of technologies. I have seen your research works, and I think I'm really interested the way you are working right now. Maybe you can tell us about your experience with some pathologies. I think you are more motivated with the stroke patients maybe you find more interested because what you think about the exoskeleton with this kind of patients?
So my motivation was always target for stroke patients, maybe for personal reasons. And then we have also talked with clinicians from Braga Hospital, and they recommend as well to go with these neurological patients. So the idea was we have acquired um, an ankle model from H2 exoskeleton, and we have to develop our research for a specific topic to assist stroke patients with drop foot conditions. And we have also considering another kind of neurological disease that also leads to drop foot pathology. So, but we have focused on this condition, motor condition, and we have focused on that because it is a common neurological disease, very common in Portugal, indeed. So it is the second cause of death in Portugal, and there are in Portugal a lack of research to recover, to get back these people to the normal lives. So the clinicians consider that it will be a good feasibility to test this new technology to accelerate the rehabilitation process of these patients. And for that, we have developed a different kind of control strategy. So our focus was only develop a different kind of control strategies. So the ankle orthosis was able to provide different kind of assistive approach for the patients, considering their disability level and their the stage of recovery, because these people can move faster regarding disability level, and even day by day they can change their motor disability. So it is needed to develop a smart control strategy that can assess in real time the patient needs and then adjust the exoskeleton system as well. So this challenge was pretty good for us to explore the control ability to adapt the sensors in real time, considering the patient's evolution, because it was amazing because the people one day can be good, another day they can be bad, and they can change fastly during the training system. So it was a challenge that we have addressed by recommendation from clinician of Hospital of Braga.
Yeah, and I think it's really complicated to continuously motivate the patients
Yeah.
because maybe you one day you're using the exoskeleton in passive mode where the exoskeleton is performing the movement, but the patient feels okay, yeah, the robot is performing the movement, but what about me? What if I want to really improve my movement? That's that kind of strategies I think is really interesting. Have you worked about this topic?
Yeah, we have worked about this topic. The main contribution from our project, Smart Project, is regarding about this topic. So to provide an assistance as needed. So the system has a number of sensors that we have developed and also use the sensor embedded on the exoskeletons. And based on this sensor information, we have developed different types of gait analysis algorithms. And based on that, we have the ability to perceive which is real-time needs from the patient and motivation as well. We have considered this topic. And based on this information, the system is able to change the systems according to the user's contributions. We can measure from different type of sensors, electromyography, inertial sensors. So this information all together, we can perceive which is the movement that the patient is doing and also his motivation, because we have also considering to introduce biofeedback strategies to encourage the user involvement on the and participation on the therapy.
And that's great because in some projects internally with Technaid, we have faced this part with patients sometimes feel, hey, I'm not doing anything different. I feel I'm not improving, and we feel, yeah, maybe we can implement with our customers some strategies like yours. Assisted needed is really important and common right now in the state of the art. So we, with our new exoskeleton, we're trying to push forward the controllers, accessing to, for example, a torque controller, motor torque controller, interaction torque controller, improving the performance of these controllers. So maybe with this background, a low level control improved, you can create or even improve your strategies. That's really cool because you're focused right now more with the patient behavior. I think so.
Yeah, yeah.
That's that's, that's
These kind
oh,
of low-level controls are quite necessary to implement these assistance need high-level controls, in particular the torque control, because we have developed six different strategies, control strategies at the high level. And we have verified that the torque control is most used in for implementing these assistance need control. So I think that our efforts should be addressed to this kind of control strategy because they are the most acceptable and from the patients. So we have to consider always the patient motivation. Otherwise, they will left behind the technology and we cannot continuously use it.
yeah, I think we have to push forward this paradigm of active, passive, and the triangle with the resistive control. Because if we are able to adapt the controller with this triangle,
Mhm.
maybe we can create a really good rehabilitation process, most close to the therapist, real rehabilitation. Because normally when we try to improve our controllers, we try to talk with therapists because we have detected that as an engineer, we only focus on improving in the controller, for example, the gain of the controller, some specific parts. But I think we have detected that maybe it's better creating these strategies from the user experience. And our user actually it's the therapist. The therapist wants to we have to get in love the exoskeleton first with the therapist because if they don't want to use, they never use this kind of new therapy. So we're trying right now to create more controllers more adapted with this triangle. You can move from active to passive with a percentage of a system, but a
Yes.
real percentage of a system. And the less a system, maybe a really good transparent controller. That's the key point right
Yeah.
now, I think, and the hot topic with the exoskeleton create a really good or real transparent controller. So
Yes.
I
I
think you have faced it with
Yeah.
your research.
Yeah,
Yeah.
it's the same. We have thought and focus on that, and also Professor Cristina at Berlab, she always motivates us to develop technology with the user-centered design. So we have a continuous meeting with the stakeholders. In this case, that they are clinicians and therapists, and also end users. And this user-centered design is completely necessary in this kind of technology because we have meetings with these clinicians, and then we realize that there are different types of needs that they want to that the technology answers. So sometimes we have a plan, but we have to change according to their needs because they are the end users at the end. So we have to change technology in an iterative design process. So we have to meet in the beginning, we design, and then we show how we have developed technology, and then they suggest and other different types of recommendations. And for the biofeedback strategy, indeed, it was very important because we are developing different types of biofeedback, visual and sonorous or haptic as well. And for that purpose, we have considered that the clinicians have a different insight how we have to develop these technologies for the patient than ours. So it is quite important to discuss firstly with them so we can develop a technology with higher adoption ability. So I agree
Good.
completely.
Yeah, I totally agree with your methodology. 'Cause that's the way to really impact with this clinician market. And I think you have used this methodology in your project Smart OS, right?
Yeah, we have developed, yeah, with clinicians from Braga Hospital, first with Dr. Fatima Pereira and Catarina, and now more recently with Dr. Cristina. So at the beginning, in the first year of my PhD, 7 years ago, I have different meetings with these clinicians. And after that, 2 years ago, and we have continued meeting. And in this last year, we have developed a webinar with different therapists from the country, from different rehabilitation centers. And we have combined different insights and perspectives regarding the rehabilitation with this kind of technology. And they provide different requirements among them. So it is interesting as well because sometimes they have different suggestions and recommendations to do it based on their own experience. So we have collect all this information and try to redesign our technology again in order to cover the suggestions of a higher number of clinicians. And these concerns are regarding the assistance need control, the way we should use sensors and where they should be placed, the weight recommended for the exoskeleton, the place where we should put the battery and this kind of stuff. So it was, we have collect all this information in a webinar. We have discussed all together. So we have designed a new design for our technology. So it is quite important to do it early as possible. So
Yeah, yeah. I think it should be always in a project the first steps, the first way to approach with a new ideas like yours. And I think in this part, you think, okay, we want to create a wearable motion lab. That's a really interesting concept. Uh, why you think it's you start working in this concept? Because
oh,
I always have seen some examples, but I think it's really interesting because you're sensing and you're actuating with the robot, and that's really cool. Can you explain us a little bit about this?
yeah, well, at the beginning, we have, when I start the SMART project, our first topic of research was regarding the wearable motion lab. Why? Because we need to include different sensing technology with the exoskeleton. And for that, we have, since the beginning, focused only on wearable because our idea was to develop a full wearable technology so the people can use in one rehabilitation center and another one rehabilitation center. And even in the same entity, our purpose was to train not in treadmill as only, but training in different environments. So level ground, stairs walking, ramps. So the idea was to develop a functional day training with activities that we face in our daily activities. So we have to develop a wearable technology for that. And we start to develop the One Motion Lab, including different types of sensors to create a multimodal sensory system that is able to provide kinematic and physiologic data as well. And well, it was our first challenge. We are always continuing improving our wearable sensors, following the 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 challenge that today there are a huge need for including sensors in our clothes and shoes. So we are working on this topic. So the technology is more acceptable for users to use a small and seamless wearables and instruments as shown with non-invasive sensors. It is our purpose. So in order to improve the user's acceptability regarding the technology. And based on this information, sense information, we needed to develop our algorithms which are able to perceive the user needs in real time and intention to move in different type of environments, in stairs, level one, or ramps. And all this information is processed in our controllers. So the exoskeleton system is adapted in real time. So yes, the Wear Motion Lab is was our first topic, and it continues to be a challenge because assessing people in free living environments is quite challenging. There are a number of issues regarding the environment and also regarding the variability. We have indeed verified that even in healthy subjects, the gait patterns are completely different. So it is
Yeah.
quite hard to have robust gait analysis algorithms able to predict the user movements even for healthy. So it is quite a challenging task.
I can figure it out. It's really challenging because maybe between women and men, you can find huge difference the way to walk. So I can figure it out. This huge challenge, and maybe you have focused, or I mean, I want to ask about the control architecture because I saw some bio-inspired control architecture. So that's based on this gate analysis, or what else? It's the bio inspiration.
So this topic of bio-inspired controller architecture starts from a paper that was published in the year that I start my PhD. So in this paper, there it involved 20 authors or 30 co-authors, a number of people around the world that had joined to talk about control strategy for orthoses, exoskeletons, and prostheses. And I remember as that right now that the paper suggests that this kind of technology should include a control strategy inspired or very inspired on human motion controls architecture. So it suggests to include to the organize the control of this kind of technology in three levels: the high level, mid level, and low level. So it is a very inspired design regarding the architecture. And the high level was regarding to include gait and algorithms that predict the gait and human locomotion intention. And mid-level are more related to the assistance need controllers, the impedance algorithms, energy-based controls, this kind of technology. And then low level, the ones that Technaid have developed with the technology, PID controls and other kind of low-level controls. So we have developed smart projects considering this approach. And for that, we have using the sensing technology and we have implemented our smart algorithms at the high level just to mimic like the human brain that predicts and decides the commands regarding the direction of walking speed. And based on the information, we have adjust our assistance need control algorithms to adjust the sizes of the exoskeletons. So it is regarding the way we organize the technology. It is a very inspiring way to organize the technology. At the same time, we have developed also systems with controllers that are inspired on human motion control strategy. The electromyographic based control, the impedance is always based on how the muscles work. So the VR inspiration, I said, comes from these points.
I'm really happy to hear that because with the H3, right now we're trying to push some concept like this high level, middle level, and low level controller. And the top of the layer, the high level control, we call that like oriented task controllers. So we use this layer performing a closed task like sit down, stand up, training, walking step by step, and continuously walking. So we close this task, and it's really easy to use with the exoskeleton right now by an Android application or using some transmission ports with the exoskeleton. And if we want to go a little bit a middle level, we offer some controllers more for researching, for example, position controller, torque control, interaction torque control, impedance even controllers. And if we want to go the lowest level, okay, we in the last version we open a little bit. You can modify the gains of the controllers. You can use an open loop controller. So I'm really happy to hear this bio-inspired concept. It's close to our idea because it's really good to use in this kind of way the controller. That's really nice. And I have another question about this bio-inspired or your experience with the controller. Because what do you think about the synchronization with the gait of the patient? Because normally when the patients are wearing the exoskeleton, we perform, for example, continuously walking, but the patient is not synchronized with the robot. So that's I think it's an issue, and maybe there are some strategies to synchronize the patient with the exoskeleton. What do you think about this?
Well, in our case, as we have ankle model just for the right limb, it is more challenging than using an exoskeleton. I am aware I use the H2 exoskeleton when I did my collaboration with neurorehabilitation group. And then when we start working in Portugal with just one model from the ankle joint, I realized that it was more challenging to use the ankle. Why? Because when we have both limbs instrumented, it is more easier to try to follow the technology, the movement that is being done by the exoskeleton. But when we are using only one instrumental link and the other one is controlled by ourselves, so it is more challenging to synchronize both links. You have to synchronize in both aspects, to synchronize both links and also to synchronize ourselves with the orthosis. So it was our main challenge, but to do it, to try to solve it, even with healthy participants, I have faced a number of issues. When I have another colleagues to test our technology, they faced the same issue, so it was a number of months to try to solve it. And for me, because I have worked a long time with the H2, I start here the sounds of the motor. So I I learned how to synchronize with
That's a
the
feedback.
technology. It's a feedback, yeah. And from that experience, we realized, so okay, we have to develop biofeedback technology so the people can be synchronized with the technology. So after that, we have started with a master thesis, and now Christiana is working on doing this PhD, her PhD on this topic. So it is quite important research. So we consider to do a PhD work on this method because it's quite challenging and we are exploring different ways and to try to find the best one. It's never best, it depends on the user, but that try to mitigate this issue. So for research, I guess that here the noise of the DC motor is a good approach, but for the patients, we have to develop more user-centered design biofeedback strategies.
But that's a good inspiration because you detect that for sure there should be a pattern
Yeah,
that helps the
yeah,
user to really perform the properly step, synchronize with the robot. Congrats, because I appreciate your work. You have a really good methodology based on the user experience, taking some information from the clinicians and creating this this lab. It's really good. congrats for your work. I think it's really interesting, and academic and even industrial community will get this knowledge really good.
Thank you. We are a great team, so we hope that because with knowledge
Perfect.
from different type, we here at the Bird Lab we combine knowledge from different insights of engineering, from biomedical is our main maybe that, and electronics and mechanics and informatics as well. So with this multidisciplinary team, we are able to look for the technology with different insights, and all together we can combine and suggest new ways to solve them. So it is our approach
That's
at Berlin. Yeah.
that's great, and actually that's my last question. What do you think is the future with your research and using the wearable exoskeleton?
Well, it is a interesting question because well, the SMART project I started 8 years ago, as I said, with my PhD. So I have finished my PhD as well 4 years ago. And during this period, we have 2 years without financial without funding to develop our research. And after that, we have got different two grants. One, the only focus on research, and the second one, we have involved local companies and research entities, and we have developed and achieved an industrial project. But this project ends 1 month ago. So our project right now, we have no funding, so we have to keep doing our research by ourselves as in the beginning. And right now we are trying to do experiments with the patients. The things has changed, at least in Portugal. So our previous ethical commission, we cannot use it. So we are trying to develop all the process to do the pilot studies with the end users, with our controllers. So we are developing all the ethical documentation to apply to the informant, so we can indeed to do the experiments. And so our topics right now are focused on that to get the ethical approval. We have right now I have joined another rehabilitation centers. We are working with different ones behind the Hospital of Braga. So we are trying to create a team for testing our technology. It is our focus now. And regarding my research, I will hope to do the experiments with the end users. And right now we are also considering to apply this kind of technology for assisted working. So we are moving to industrial challenges as well to try, because we have always focused to assist people, so we can assist people in the hospital or in the work. So we are considering this topic for our research.
That's amazing to hear. I hope you get good results with your research and your project. Thank you so much for
Welcome.
your time. Thanks for attending our podcast, and
Yes, of course.
I hope to speak with you really soon.
See you too. See you soon. Bye.
See you. Bye.
Bye.